So this first part of the lesson is basically just a review of what we did last time, but we're also adding in ln of x, and some of the problems will get a little bit trickier. So in this first section, it says without the use of your calculator, determine the values of each of the following. So we know whenever we see this ln, that means log base e. So in the spot where ln is, I'm going to write log base e, and then I'm going to copy that e that's already in the problem. So this question says, what exponent for e would give me e? So we know if something doesn't change, right, the exponent is just 1. So e to the first is e is basically what we're saying. The next one, what exponent for e gives me 1? So we know that the exponent that always gives us 1 is 0, right? And that is because e to the 0 equals 1. Remember, this second line I'm writing is just kind of a check. This is my actual answer. Okay, so these two are my answers. So why don't you try some of the rest of them? These are really just making sure you understand that e. So if you've done this one, what exponent for e gives me e to the 5th? That exponent is 5. This one, what exponent for e gives me the square root of e? Well, the exponent that is the square root or means the square root is the 1/2 power. So getting over to the next section, these are not natural logarithms or ln, these are just regular ones. Now I'm going to talk about how to think about one of these first to get an answer, but the rest of them I'm going to switch over to exponential form because they are kind of tricky to figure out in your head. So when I look at my log base 81 of 27, I think of 3 being that common base. So if I think about what would I have to do to 81? Well, to get it to 3, I would have to take a 4th root, right? Because 3 to the 4th is 81. And then to take that 3 that I found and make it into 27, I would have to cube it. Okay, so that would be my answer. Okay, now that's pretty tricky to do, especially because, I've been doing exponents for a while. You guys are just learning them. I would suggest taking what we have here, I'm just going to write it in a different color, log base b of a number equals the exponent. Right, that's what we have here, and I'm going to put it in then or exponential form. So my base is 81, my exponent is the x, and my number is 27. So once you get it like that, it's like the common base problems we did a couple lessons ago. So 81 is 3 to the 4th, 27 is 3 to the 3rd, and then I'll rewrite that x. Cancel the common bases. So 4x equals 3. So dividing by 4, x equals 3/4. So that's another way when I see that answer, I can know that this answer up here is 3/4. Still, if you can figure them out in your head, you need that backup plan if you can't. But that's great. If you can look at these and figure them out, that shows that you know those powers you need to know pretty well. So I'm just going to erase this so I can get that out of the way. The next one, what exponent for 4 gives me 1/8? So I'm going to put this in exponential form. My base is 4, my exponent is x, and the number it's equal to is 1/8. So that's just switching from Benny to Ben form. So the 4 and 8 are powers of 2. So 4 is 2 squared. 1/8 is 2 to the negative 3rd. I'll just bring down that x. So I have 2x equals negative 3. So x, when we divide by 2, equals negative 3/2. The next one, log base 125 of 1/25. Set it equal to x. This 125 was kind of weird, but I was already heading up to the exponent when I wrote the 5. So 125 and 1/25, common base is 5. So I have 5 cubed. Over here I have 5 to the negative 2 because I have a fraction. So that gives me 3x equals negative 2. So this one is x equals negative 2/3. And the last one in this section, you can write it out. As always, I'm going to do one more maybe where I think about it in my head. So 32 and 64, the common base would be 2. To get down to the 2 from the 32, I would need to take the 5th root because 2 to the 5th is 32. And then to get back up to 64, I would need to take that 2 and raise it to the 6th power. Powers go on the top, roots go on the bottom, so that one would be 6ths. And if you set it up, it would be similar to the last 3 that I did, putting it in exponential form. So the second section is where we have our log equations, and each of these we basically are just going to put in exponential form, and then we can solve whatever we have there. So I'll write this out one more time. When it's in log form, this is where the base, exponent, and number are located. When we switch over to exponential form, we put the numbers here. So I have x to the negative 2 equals 1 over 36. So maybe I know that number is 6 because 6 to the negative 2 is 1/36. If I want to do this basically with a solving method, I just use the reciprocal exponent, or I could take square root to the negative 1, but this is probably easier. This you could just type in your calculator, 1/36 to the negative 1 over 2, and I would get that the answer here is 6. So looking at the next one, base to the exponent equals the number. Here's another one where I need to get rid of a numerical exponent. So I'm going to raise that to the negative 3/2 to cancel it. So reciprocal exponent. So just to kind of get an idea, as I said, you can just use your calculator. If I have a fraction, then with a negative exponent, it's going to flip it back over. So I could think of this as being like 25 to the positive 3/2. Square root of 25 is 5. 5 cubed is 125. So as I said, definitely can do that in your calculator, but that would be your answer. So my last one, the base is 64. The exponent is 1/2, and that equals x. 64 to the 1/2 is the square root of 64. So that is just 8 as my answer.